No,
I don't
no,
allow
they
them
don't
to
because
drive.
Cora leaves school early to go to Greencastle, and then like Rachel has her own car. They drive separately.
Are you sure?
I'm sure. We talk about it in history.
I don't know. I don't allow Deborah to drive because she has no idea what she's doing. The only time I let her drive was when I hurt my neck and I couldn't turn, and I pulled back behind me, and then she was driving, and I was just gonna see like really scary.
How's my brother's birthday?
If a function has a local maximum or a local minimum at an interior point, so not an endpoint, of its domain, and if the derivative exists, then we can say that the derivative of that local max or local min would be 0. And we've talked about that. If you have a graph that has a turning point, the slope of that tangent line is always 0, right? Horizontal tangent lines? Yes? No? Maybe?
Yes.
Why have we spent so much time talking about that? Because that's how you can find your own max and mins. If you know where the derivative equals 0, then you can find your max and min. So this is kind of super, super important. So we say a point in the interior of a domain of a function where the derivative equals 0 or the derivative is undefined, we call that a critical point of the function.
Government's gonna be smart today with how those two. It'll be me and Mallory and Tyler.
Maybe they'll come like it's weird that they're both in C. That makes us suspicious. Like if it's just one of them. You're gonna get married. They're nice, but they're gonna get married.
No, Rachel
I don't
said,
think
yeah.
anyone can put up with those two, but
Except each other, yeah. Rachel said she went to Sean's birthday party and Sean's ex-girlfriend was there, and then Sean's like boss or his family member, one of them said, "Wow, we like her way better than the other girl," and Rachel's like, "Not his girlfriend."
yeah, but it was Ellen. And I didn't mean for that to sound mean, but she's like really quiet.
Wow, it was Ellen.
No, it was not.
I was.
That's not what I meant.
No, she's like really quiet and like doesn't speak, and then she stares. She has a staring problem.
And you know what? Hey, listen to me. I'm recording this. This is recording right now.
Sean will know. Sean will know. Sean won't listen to this. He'll be like, I know how to do this. And
He'll
then
come in tomorrow and be so mad at you.
Hey, Kimberly, I know how to do
This is all Kimberly, not me. I know nothing of your ex-girlfriend.
I wasn't being mean, Sean.
They know that we think they're gonna get married. Caitlin started it.
So here's a big important thing today. To find local extrema points, all you need to know are your endpoints, because it could happen at endpoint, and you need to find your critical points. So today, they're not going to give you graphs. Today's going to be a little bit more work.
We do graph ourselves.
Nope, you don't need a graph. That's the best part of it. So if you look at a graph, it's cheating, because, you know, you can just look at a graph and see what the highest lowest point is.
I made graph.
You could, but some of these are not going to be very pretty to make a graph of.
What if you're doing graph?
That's cheating.
Not right neatly. Yesterday or today.
I can't write neatly ever. Oh, he's here. He won't have to watch the video.
Sonia, I'm still there. Is Rachel with you?
Nope.
Okay.
We were concerned that you were both gone.
Yep.
Are you okay?
No.
Did you have a bad morning?
Yep.
Katie had a flat tire.
My car won't stay running.
I was late to swim practice.
Did you have
I
to
didn't have
push it?
breakfast or lunch.
So did you.
Oh, I had to have my mom
Sean,
brought
let's have a competition. This takes some days too.
We've had a rough day,
We all have had rough ones.
but yes, that
I'll
stinks.
get better.
So it starts and it just dies.
It started fine, and I tried getting my stepdad to help me because you know he's a mechanic, and I texted him and I'm like, hey, what could be
went downhill from there.
I would have not come to school.
I considered it, but then, Miss Thompson probably would home and be like, oh, you just skipped so you didn't have to come to my class. And be like, yeah, you're right. I just skipped just so I didn't have to come to just your class.
You should have seen her at the basketball game last night. She was yelling at the
She was so funny, like the dad called me. What?
Because I don't know if she was planning on leaving, but she like got up and then she just stood in the doorway and she was like yelling at the back.
It was so great.
I love her. Sawyer was gonna kick out of it. I know. She kept looking at him. He's like, oh. He was talking to Sawyer. He's like, what about home court advantage? And the ref just came over and started talking to him.
Absolute extrema. We need endpoints and check the endpoints because remember, just like yesterday, we talked about extreme value theorem. It could occur at the endpoints. But the new part is we also have to check the critical points, which means we need to find where the derivative equals 0, where the derivative equals 0, or where the derivative is undefined. So step 1 on these problems is you are going to find critical points. Which means you got to be able to do the derivative. Oh, I am recording. Oh, that's right. You can still hear me, right? It just makes a loud noise and scares people when it falls out. So,
Does that say f prime of x equals 0?
yes, that's the definition of a critical point, where the derivative equals 0 or where the derivative is undefined. So step 1 on this is we need to find our derivative. What would the derivative of x to the 2/3 be? Subtract 1 from 2/3 and we get negative 1/3. Or we could write that as 2 over 3 x to the 1/3, or the cube root of x, however you want to write that. Agree with me on that? Now I need to find where does that equal 0, or where is that undefined? So undefined, you can just look at that and tell me, is there any place where this would be undefined? At what value could I not plug into this derivative? 0, because I can't have 0 in my denominator. Are you with me on that? So I could say, I know that x equals 0 is a critical point because, I'm going to write underneath here, because f prime of x is undefined there. What if I try to solve this equal to 0? If I say 0 equals 2 over 3 and the cube root of x, you have to try to solve it. The question is on this one, if we multiply the denominator over, this is just going to cancel out and give me 0, and I'm going to be left with 0 equals 2. So is that ever going to equal 0? No. Which means in this case, I only have one critical point. This is my critical point. Where does it equal 0? Where is it undefined? And in this case, it's not ever equal to 0. It's undefined at one spot. Now I want to see which is the max and which is the min. So now, step 2, you're going to check your critical points and your endpoints. And I'm just going to plug those numbers back into my original function. So I have to check 0, because that was a critical point. I have to check negative 2, and I have to check 3, because those are my endpoints. So if you want to write that on your notes on this first one, like this is your critical point, and these are your endpoints. How are you going to know which one is the max and which one is the min when you plug it back into the function? The biggest number is going to be the max, the smallest number is going to be your min, because your max and min can only occur at endpoints or at a critical point. That's the only places. So you don't need a graph to do these problems. You just need to be able to take the derivative. So I'm just going to plug that in. And if I plug 0 in here, I'm going to get 0 to the 2/3 power, which is just 0. And these are not very pretty numbers. You can just use your calculator and get a decimal. If I plug negative 2 in there, That's negative 2 squared, and then the cube root of that, like that would be like the cube root of negative 2 squared. Doesn't matter which way you do it, but that negative 2 squared is 4. That's like saying the cube root of 4, right?
We leave it like that, or do you want to?
You can leave it like that as long as you know which one's bigger or smaller, and that's why we'll talk about that in a second. If I plug 3 in there, I would get the cube root of 9. Do you agree that the cube root of 9 has to be bigger than the cube root of 4? So if this was on a no calculator question, you could still get the answer without doing it. If you type it in your calculator, this is like 1 point something and this is 2 point something, so it does work. So that means I can say that I know that this is the maximum and this is the minimum because it's the smallest. I think it's better to like write it out as your answer. Like I'm going to say the minimum occurs at 0, 0, or you could write it like we did yesterday, a minimum of 0 at x equals 0. I just like to show it you different ways here. And the maximum of this one occurs at 3, and the cube root of 9 would be my answer. So definitely a little bit more work today. The idea is that you shouldn't be graphing these on your calculator to get your answers. If you do this work and then you want to check it on your calculator and graph it and make sure that's the maximum, and I'm okay with that. But I'm looking for this work to go with this, and that's why when we have our test, there'll be no graphing calculator allowed on a good portion of it. Because definitely on the AP test, they expect you to be able to do this without a calculator. Let's do another one. Let's do another one.
Oh, it's E. It's my favorite.
Again, notice it's a closed domain, so that means e to the negative x is a continuous function. It's a closed domain, so I can use the extreme value theorem to know that I should have a max and I should have a min. It can occur at the endpoints, but I also need to check to see if it occurs anywhere as a critical point. So again, step 1 is find your derivative. What would the derivative of e to the negative x be? Negative e to the negative x. Critical points, I need to set this equal to 0. Also undefined. Is there any value of x that would make this function undefined? No. E to the negative x has a domain of all real numbers, so it's not undefined anywhere. So all I have to do is try to solve this. If you remember about e, you might know the answer right now, but maybe we could just try to solve this. Could I divide both sides by the negative to get rid of the negative in front of that? And then I just have 0 equals e to the negative x. And how do I get that x out of the exponent? ln both sides. What's the ln of 0? Can you take the ln of 0? That's undefined. Which means, just like the last one, this doesn't ever equal anything. Which means there are no critical points for this function. If you think about e to the x, if you think about the graph of that, or negative e to negative x, it's like one of those exponential graphs, and so it doesn't have any turning points on it, which is why it has no critical points. But what else do we still need to check for the max and the min? The endpoints. One of them is going to be the max, and one of them is going to be the min. You just got to plug it in and make sure you know which is which. So on this one, because there's no critical points, I only have to check endpoints. Like that. Check endpoints. So I'm just going to plug in -1 and 1. And again, you should be able to give me answers without decimals. Just leave it in terms of e. That's a better answer than give me a decimal. And remember, you don't plug into your derivative. We're trying to find the point on the graph, so we always go back to the original function. So I would get e to the negative of -1, which is really just e. You're with me on that? negatives cancel out. And if I plug in 1, I get e to the negative 1, which you can leave as e to the negative 1, or I like to write it as 1 over e. I think it just looks better. So which one of those is bigger, e or 1 over e? E. So that means this is my max, so I can say that there's a max at the point negative 1e, and there's a minimum at the point 1 over e. We're going to do lots of stuff with ln and e because it shows up on the AP test all the time. On the no calculator part, they like to know that you know how to solve those equations, that you know it never equals 0, that you know how to simplify it. So ln and e are going to become our good friends. Let's do one with trig. What do you notice about the domain of this one? It's behind the circle, which is good. It's secant and tangent. I mean, sorry, secant. Look at the domain of this one and the domain of this one. It's not included, which means when I'm checking max and mins, am I going to check negative pi halves and 3 pi halves? No, because it doesn't include the endpoints. So just maybe write that, not included. Which means my max and my min can't occur at those endpoints. Secant is what, 1 over cosine? Right? I think it's not included because is secant of those values undefined? Anyway, not included, don't check it. But we can still do the derivative. And what's the derivative of secant x? I just told you. Secant x tangent x.
I always do that. I did that yesterday. What did I say?
So we need to set this equal to 0. Kind of have some options here. We could break that up and say where does secant equal 0, where does tangent equal 0, and try to work that out. We also could try to simplify it. Like when I did this, I changed it to sines and cosines. So let's see if this makes any sense to you. I wrote this as 1 over cosine of x, and tangent is sine of x over cosine of x. So nothing cancels out, but I could rewrite that as sine of x over cosine squared of x. So if I'm trying to set it equal to 0, do you agree that the bottom really means nothing in terms of setting it equal to 0? Because every time you can multiply that over and it goes away. So I like writing it as a fraction if I can, because I can just say, I'm just trying to figure out where does sine of x equal 0. Remember, we're restricted here on our domain. We're just going from negative pi halves, which would be like down here, all the way around. That's weird. But we have to give answers from negative pi halves all the way around. So where would sine equal 0? At 0 and pi. We're also supposed to look at where it's undefined. So that would be where cosine equals 0. So that's in the bottom. So undefined would be where cosine equals 0. But negative pi halves is not included, right? Pi halves, did I say that? And then I'm back to the 3 pi halves, that's not included either. So we actually end up with 3 critical points on this one. And now I just have to plug them in. I don't have to plug the endpoints in, but I do have to plug these in and see what's happening. So I'm going to plug in 0 and pi and pi halves into that original problem. And again, yes, I expect that you can do these trig things without a calculator. This is where I'm a triangle fan, but secant is 1 over cosine, so if you know the cosine of these, you're just going to flip it over, right? So what is the cosine of 0? 1, so if we do the reciprocal of that, it's just 1. So secant of 0 is just 1. What is the cosine of pi? No, because we're trying to find the max and min, which means we're going back to the original. Right? Like we only use the derivative to find the critical points, and then we go back to the original problem. Pi's over here at negative 1, 0, so the cosine's negative 1. You flip it over, it's just negative 1. You with me on that? What about the secant of pi halves? What's the cosine of pi halves? So what's the secant of pi halves? Undefined. Which means this cannot be a max or a min if it's not even defined on my graph. You with me on that? The same reason these are not included. Those are asymptotes on secant. Remember, secant has those asymptotes, and it's like those upside down, like the u up, u down. That's why that's not included either. U up, u down. So I think we could say that we have a max at the point pi negative 1. That's not a max. That's a min, right? Because negative 1 is smaller than 1. I'm going to change that just to min, so I don't have to erase the other part. And the max would occur at 0, 1, because the y value tells you what your max and your min. This is going to be fun today, isn't it? So Phineas and Ferb song.
Yeah, that's actually, I sing it. I actually didn't even think of SpongeBob before this.
Oh, yeah.
Oh, I can't pay. I like half my face was.
Notice on this problem, it still says find the extreme values and where they occur, but they don't give you the domain here. So you have to think about the domain yourself, and we might have to look at a graph to help us still find critical points, but we might have to look at a graph right now until we learn some more calculus that we haven't learned yet. So step 1 on this is, could you tell me the domain of this without graphing it? Could x be anything on this problem? Can't be 1 or negative 1, because if you see a denominator on a problem, then you can't have a domain of all numbers if there's an x down there, right? So the domain on this, you could say it has to be not equal to 0, like the denominator cannot equal 0. So we could say that the denominator cannot equal plus or minus 1. So that would be like what? Negative infinity to negative 1, negative 1 to 1, and 1 to infinity. You're going to write that out super fancy? Or it just can't equal plus or minus 1? That means our domain is definitely not closed, so the extreme value theorem does not apply, which means there's no guarantee that there's a max and there's no guarantee that there's a min. Eventually, in the next couple days, we're going to learn how we can still use calculus to do that. But today, if you see a problem like that where the domain, the extreme value theorem does not apply, you're going to maybe have to look at a graph to help you. But I still want you to practice with your critical points, and then we'll go to the graph if we need to. So let's do our derivative of this and see what we can figure out. You have some choices on this. Do you want to do the quotient rule, or do you want to bring that up and make it to negative 1 power and do the chain rule? Let's take both. Who wants the quotient rule? chain rule? Who didn't vote?
Well, I did it anyway, so.
That's alright. It works either way. We'll get the same answer eventually, but I'll do the quotient rule. I like the chain rule also. I'm just gonna throw that out here. If you wanted to do the chain rule, all you have to do is bring that out, leave that alone, multiply by the inside, and you're done with the problem. I'm a big fan of the chain rule. But quotient rule, you have to take the derivative of the top, which would be 0, times the bottom, which is x squared minus 1, minus the derivative of the bottom, which would be 2x, times the top, which is 1, all over the denominator squared, which is x squared minus 1 squared.
Or you could wait or skip all of the work that you wasted and then throw it in to write 0.
Well, I'm just doing my formula. But it's the same thing that you get either way. That's why it's your choice. Because if you do the chain rule, the derivative of the inside is 2x, but the negative comes from the -1 that you bring out front, so that's why it's -2x. And when you subtract 1, you get -2, and you move to the bottom, and that's where you get this, right? So either way, you should end up with that derivative. What are my critical points here? So which one do you want to do first? Undefined or where it actually equals 0? Let's do where it actually equals 0. Again, I hope that after you do a few of these, this is like the third one that we've done with the fraction already. When you have a fraction equal to 0, the denominator is never going to equal 0. And actually, if you were solving this, you could multiply the denominator over, and it's just going to cancel out because it's going to equal 0 on the other side, right? So all you have to do is set the top equal to 0, and you would get that x equals 0 as a critical point. With me on that? The other part that you have to look at is where it's undefined, and you need to just be able to look at that. And if you see a fraction, you definitely should be able to tell me what can't x be in this derivative. Undefined at x equals plus or minus 1. Now this is the first one that we've had like this. The original problem was undefined at plus or minus 1, right? And my derivative is undefined at plus or minus 1. Which means, can I plug plus or minus 1 back into that problem and see if there's a max or a min there? No, because it's undefined there. So the nice part is if any of your critical points are undefined in the original problem, they can't be a max or a min because they're undefined. So I'm going to put undefined in y, so don't have to check. Again, that's just kind of notes for you to have. So if you ever get a critical point and you plug it back in and it's undefined, don't freak out about it. It just means, oh, I don't have to check that when it's undefined. Which means I only have one critical point. How do I know if it's a max or a min? We haven't learned that yet, which is where you have to go to the graph to help you. But we could go ahead and plug it back in and say, if I plug 0 into that problem, what am I going to get? -1? Right? And if the derivative equals 0, it should be something, either a max or a min. Right now, we don't know. So on your homework today, I'll even tell you which ones I think you need to look at the graph. We need to look at the graph of this. And that's where I'm okay with you using your graphing calculators, which means if you're not in the habit of bringing your graphing calculator, you might want to do that over the next few days because we will use them at times. Did you just sign in at the office? That's fine, they fixed it. As long as you're in the office, I don't have to do anything because they'll fix it automatically.
Why do they ever parents can't run the sign?
Well, that's if your parent comes to pick you up early, they have to sign it. Yeah, but if you drive, they don't. But for little children, they do. All right, so if I was going to graph this, that would be 1 divided by, I have to put that denominator in parentheses, x squared minus 1, parentheses, and my window's all screwed up, so I'm going to change this to Zoom Standard. And we know it's undefined at -1 and 1, That's why, what's this other line on here? Oh, look, I have one graphed up here. It's like, why is that? It's undefined at -1 and 1 because it has those asymptotes. We found the point, what was our point that we found as a critical point? 0, -1. Is that a local max or a local min on this graph? Max, right? I know, but compared to the points around it is what you're looking at. So since the points around it are smaller than it, it's like a turning point where it's going up and then it turns and goes back down. That would be a local max at 0, -1. Eventually, like really soon, maybe next week or two, we're gonna learn how to do this without graphing it. But right now, you get to graph a couple of them. Okay? Last one. Last one. Told you we were gonna. You're not gonna have time to do homework. I'll go back to the beginning in a minute. You just missed the definition of a critical point, which is when the derivative equals 0 or is undefined. And every time, if your derivative equals 0 or is undefined, that's where a local max or min is going to occur. If you think about when we talked about horizontal tangent lines always occur at those turning points. So that's how you find this. What do you know about this graph just by looking at it? The domain is all real numbers. It's going to be some kind of polynomial function, not necessarily just S-shaped because it's not just X cubed, but it could be S-shaped. What do you know about the arrows on this one? Yeah, it's an odd. The leading coefficient is odd, which means the arrows are going to point in opposite directions. Which means, is it going to have an absolute max or min? No, it could have a local max or min, but it definitely isn't going to have an absolute max or min. So without graphing this, I could say that I know it has no absolute extrema points or max or mins. But to find the local extreme, I think we might need our calculator here to help us. But we could we take the derivative of this? This is like the easiest one so far, I think, taking the derivative of. Would be what? 3x squared minus 6x plus 3? Is that going to be undefined anywhere? Can I solve that? Factor, complete the square quadratic formula? What could I do first to make that an easier problem to solve? Yeah, I'm just going to divide by 3, so that's going to make that x squared minus 2x plus 1. Is that factor? What multiplies to give me 1, that adds to give me -2, x minus 1, x minus 1. Which means I get a critical point at x equals 1. But just like the last problem, because the domain is all real numbers, and because it's only one critical point, I don't know if that's a local max or a local min without looking at the graph. And so this is another example where you have to look at the graph to see if that is a critical point. So let's see if I can graph that one real quick, and I'll stop. You didn't get -1?
Or I got -1 now. Because I was.
Oh, because, okay, I'm with you. But you agree that I'm right?
Minus
3x squared.
plus 3x minus 2.
Because I did it like, I didn't divide by 3.
I'm with you.
So
you
got negative. Because I subtracted 3 over, and I factored in 3x, and so I did 3x equals negative 3, and then x minus 2 equals negative 3.
I'll look at it. I really think I'm right though. Wait, am I right? It's 1, right? Okay. So at 1, we can look and find this value. It's right there. Is that a max or a min? Or neither? That's an example of a critical point that doesn't give you either one. This is a fancy little thing that we call a point of inflection that we're going to learn about because the graph changes curvature here, curve there. But that's not a max because there's points right over here that are higher than it. It's not a min because there's points over here that are lower than this. So the answer to this question is there's no extrema points. There's no absolute max or min because it keeps going in both directions. And there's no local extrema to this graph. And again, right now, the only way we have to tell that is by looking at the graph. But I do want to see the derivatives on your homework on these problems. So the answer to this, I would say, is there are no extrema, no either one, local or other one, like I wrote. There you go. All right, so those are the ones I think on the homework that people get stumped by because you have to keep doing the derivatives for a while, and then you get to these that you're supposed to look at a graph, and we'll probably talk about those tomorrow. But polynomial functions, you kind of need to look at a graph today. Oh my gosh, I had another one. I think on your homework it says 11 through 30 odd, but 30 is not an odd number, so it's still the same homework. You just don't do number 30 because it's not odd. I gave you odd ones again because I want you to be able to check your answers. But again, I know how much work this should take. Like I have, which I use a lot of paper, but I have front, back for this assignment. So I know how much work should be there, and I know if you're just coming on the back of the book when I look at these on a homework quiz, if you just have an answer and not work to support it, that's going to be a problem. I can tell you that I wrote 19 and 21 are the ones that I used my calculator on a lot. So let me write that down. 19, 21, calc. That means calculus. Go right, yeah. Maybe it's also like Katie go write her paper.
Yeah, I have it, but and you don't do anything. And I don't do it. Just you have to read that story. Well,
Have to read that
story.
I never read that either. Oh well.
I just read the Children.
That was really weird.
I don't know.